So our cascading failure simulator, we need an engine for it. So we need something that's actually going to churn through and do all these simulations. And we're using DigSilent. So DigSilent is just a power system dynamic software simulation package. We use that because we've got a lot of experience using it in Manchester. And we have a lot of experience using it in Manchester because National Grid use it in the UK. They use it as their like default power system simulator. So we've built up expertise and skills using it to make sure that we can then translate our work into industry and have some industrial impact coming out of it. We need to model synchronous generators. So as I said, we're ignoring the voltage stuff. So we're just modeling these as classical second order models. So that means it's got a swing equation. It's got a couple of dynamic states associated with the mechanical system. But from the voltage perspective, it's just a constant voltage output. So we've got no voltage control associated with those, but we do have the primary control. And apparently we've got secondary control. For demand, demand doesn't matter too much. We are actually modeling it with a zip model, but like I said, we're not worried about the voltages in the system. So the actual voltage dependence within this doesn't really matter. This could just be a constant PQ load. It would be the same result. We have some frequency dependence on the demand, but it's quite small. It doesn't have a big effect on the result. And then in terms of protection, whoops, where did that go? In terms of protection, we need to have over/under frequency relays on our synchronous generators. So they'll trip out if the frequency gets too high, they'll trip out if the frequency gets too low. They have an out of step relay. So essentially if they over rotate and they lose synchronism, they'll trip off. We have thermal protection on the lines. So if the line gets too hot for too long, we trip it off. Some countries don't actually do that. They will manually do that. They will use it thermal alarm systems, but they will rely on a manual tripping. We obviously need to automate this within the simulation. So we automate a thermal protection on that. And we have under frequency load shedding as well. So we have the kind of standard tiered under frequency load shedding. So as the frequency drops, you disconnect your load in slices. And I think for this, we used whatever the US setup is. I can't remember off the top of my head, but we use the same kind of under frequency limit.